very interesting, very amazing, very important, and very. Give me the last word in the comment section. Now we are going to be looking at chemistry and the topic organic compound, the subtopic hydrocarbon, which is the most interesting part of what I'm going to talk about today. Now, what are hydrocarbons? As you can see, hydrocarbons. This is hydrogen and this is carbon. Now, hydrocarbons they are compounds of just hydrogen and carbon, which are just two elements, compounds of hydrogen and carbon, and they are the simplest form of organic compounds. Yes, I would say they are the simplest because they just possess only two elements in their compounds. Yes, they come together. These two elements come together to act as one unit. Now, they have different. They have two types of hydrocarbons, and they have different forms. I mean, let's say different forms, or should I say different characteristics and different members of hydrocarbons. Now, now we have two types of hydrocarbons. We have the aliphatic and the aromatic. Okay, well, now the aliphatic are cyclic, which is they are straight chain or they might be bent chain, but they are not cyclic. While the aromatic they are cyclic, which is they are in form of circle, a ring. Yes, this is example of the aliphatic. We have the ethane, which is the second member of the alkane family. And then the aromatic, an example, we have benzene. Benzene. This is C2H6, and this is C6H6. Capital letter. Now, these are the two forms, the two types of hydrocarbon. This is ethane being an aliphatic example. This is benzene being an aromatic example. Now, let's move to the characteristics of hydrocarbons. Characteristics of hydrocarbon, we have one, they have a general molecular formula which is stated as CnH2n. This is the general molecular formula for all hydrocarbons, whether alkane being the first family, alkene being the second family, alkyne being the third family, alkanol, and so on and so forth. But this is their general molecular formula. You get. Now, let's list the types of the families of hydrocarbons. I think I'll list just four, although there are more of them. I'll list just four and give us, let's say, we'll talk about as many as we can, as time permits. Now we have the alkane being the first family, alkene being the second family, alkyne being the third family, alkanol, alkanol being the fourth family. You get. Now, this has a general molecular formula of CnH2n. H2n. This also has a general molecular formula of CnH2n. This has a general molecular formula CnH2n. This has the same formula, which is CnH2n. You get. Now, another characteristics I would like to show you guys is one. Each successive member differs by the addition of the CH2. As in, for example, methane, which is the first member, which is this methane, is CH4. CH4. While ethane, which is the second family, the second member, which is this one, is now C2H6 again. Now, the reason if you notice the difference, yes, the addition of these two and an addition of 2 to this 4, which made it 6. You get. So this is what I mean by the addition of CH2 group. You get. So that's another example, another characteristics of the alkane family. Now, I think we should go into the next thing we should go into is the alkane family. Let's look more at the alkane family. Take time. Okay. Now, the alkane family has its own formula, which is what we used to note that this is an alkane family or alkane member is CnH2n. plus 2. Now this plus 2, notice it was not there in our last formula, which was CnH2n. This is the general molecular formula for all hydrocarbons. Now this is the general molecular formula for alkane, which is the family of alkanes. Yes, this plus 2 made it different. You will notice as we go down, you will have the one with just CN. Don't worry, as we go down, we'll see that. Now, the general molecular formula for alkanes are CnH2n plus 2. And we have different members in the alkane family. Let's look at some of them. We have the methane, which is the first member. Methane. Sorry. Ethane. Now, this is methane, this is ethane, and this is propane. This is butane, and this is pentane. We have the hexane, the heptane, the nonane, and all the rest. The decane, you get. This is methane being the first member. This is ethane being the second member. This is 1, 2, 3, 4, 5. This is methane, ethane, propane, butane, and pentane. But means 4, pent means 5, prop means 3, ethane, methane, and all the rest. Get. Now the formula for methane is going to be C. No, let's follow this formula to derive the methane formula. Remember, this N is the number of carbon, this H is C is carbon, this N is the number of carbon, H is hydrogen, this is 2, and this N is the number of hydrogens we have. Yes. This is C, which is carbon. How many carbons do we have in methane? We have just 1. So we have our N at 1. Then we have the H. How many? Okay, the H, the next number there is 2. Then N. N is still 1. The N is still 1, which is times 1, because 2N is times 1. Then plus 2. Remember this for alkane. This is the general molecular formula for all hydrocarbons. But this is for alkane, and it's alkane we are looking at. Yes. So we are going to use this formula to solve. We use this to derive this. We use this to derive for alkene. We use this to derive for alkyne, alkanols, and all the rest. For looking at the alkane, we have to use this to solve for each member. Now, to get the methane being the first member, remember I said C, which is the carbon number of carbons, N, which is 1, H, which is the hydrogen, 2, which is this 2, which is also this 2, times 1, because this N is 1, times 1 plus 2. So let's say the solvent is going to be, since it's C1, there's actually no need of writing this 1 again, so it's just going to be CH, 2 times 1, we have 2, and then plus 2, we have 4. So CH4 is the formula for methane, which is CH4 is the formula for methane. Now go down to ethane, being the second formula. You notice it will be C as the second member, third, fourth, fifth, and sixth first. As the second member is going to have C, remember I said here is N, which is the number at which this, or number of carbons which this each element possesses, and then the number of which is each member, and then it also stands for the number of the position at which that number stands. This is ethane, which is 2, H, this number is 2 times 2 plus 2, C2, Cn, H2, H2, N is still 2, which is put there, and then plus 2, which is going to be equals to C2, H. Remember, this was C1, so there's no need of putting it there. But since it's C2, because if you put C1, you see the same thing as saying C. You know that it's 1. But once you say C and you have C2, you can't really say it's 2. So you put the 2 there to differentiate it from this CH4. So C2, H2 plus 2 times 2, which is 4, 4 plus 2, we have 6. So for ethane, we say we have C2H6 as our formula. Let's go down to propane. C3H2 times plus 2. This is going to give us C3H8. Going down to both, C4H2 times 4 plus 2 is going to give us C4H10. This is C5H2 times 4 plus 2 is going to give us C5H12. You get C5H12 is for pentane. C4H10 is for butane. C3H8 is for propane. C2H6 is for ethane, and CH4 is for methane. Now let's look at the structural formula. Note. Now, the structural formula of each member also helps you to know the member you're looking at. Now, for methane, which is the first member, remember our answer, or should I say our formula for methane was CH4. It was CH4. So the structural formula is going to be Note, this is C, which is just one C, and this is H, this is H, this is H, this is H. We have CH4, C and H4. We have 4 H's in this. Let's say H's, 4 H in this member. This member carries 4 H. Now note, this is a single bond. This is a bond between this thing. This is a single bond. This is a single bond. This is a single bond. So just know that all methanes are single bond, which is their saturated members, or should I say saturated family. So all alkanes are saturated and they are single bond. Methane is the second member, so it's going to be C2H6. So it's going to be stated as C12. If you notice, in this one we have just one C, and in this one we have two C's. And this is the bond between the two C's. These C's show you the number of carbons we have, the number of carbon chains we have, and then this one, they are the same thing. We have 1, 2, 3, 4, 5, 6. C2H6, 1, 2, C2, 1, 2, 3, 4, 5, 6, H6. That's what we mean by structural formula. This is their molecular formula, this is their structural formula. Then what we call their empirical formula. This is it. For CH2, for ethane, sorry, going to be CH3. Now, remember I said this is your molecular formula, this is your structural formula, and then I'm going to give you the empirical formula right now. The empirical formula of the ethane is going to be CH3 bond CH3, because this is our molecular formula. Now, the reason why it's CH3 is because this C has 3 hydrogens. Yes, this C has also 3 hydrogens. If it's a situation where we have butane, for example, the empirical formula is going to change. Sorry about this. Butane is going to be C4H10. its empirical formula, or let's say its structural formula, first of all, is going to be 1, 2, 3, 4. This is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4. This is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4, this is going to be 1, this is going to be 2. Now, this is the structural formula for butane. And then the count is 1, 2, 3, 4. Four carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen. So C4H10. So note, if it's this way, then the empirical formula is not going to be C3H3 again. What you're going to have is C123. I'll slap it there. C123 is going to be CH3. This one does not have this second C, which is the second carbon, does not have up to 3 hydrogen, just as the first one has. So it's going to be CH2. One, two, three, CH3. You get this is CH3, CH2, CH2, and CH3. I told you the empirical formula is going to change. The empirical formula of this one was ethane was CH3, CH3. But for butane, it has changed because this one does not have up to 3 hydrogens. This one does not have up to 3 hydrogens, but this one has 3 hydrogens. So it has changed. There's something I also want you guys to know. Since for an element, for an atom, or let's say for an element, a compound to create bonds in between its own atom, is what we call catenation. For it to create a bond between this hydrogen and this carbon, carbon, this carbon, this carbon, this carbon. Or should I even use this one? It's better. C, C, H, H, The main thing I want to show you guys is this. For it to be able to create a bond in this point, or should I say at this point, is what we call catenation. Catenation. Let's start from there. Catenation. Well spelled. I think I should bring it down this way. It's what we call yes. Now, catenation is the ability for a compound to create bonds in between its own atoms. Alright, I think we're going to stop here for today, but for more of this, I think you should give me a follow button, which is subscribe to my YouTube channel, and then like the video. But first of all, drop a comment on the comment section to tell me if it was helpful or if you want more of this. But please